Okay, so now, hopefully you guys got started with this. Everyone should be okay. So the first question asks, it says, Karen's aunt plans to bike 10 miles. How long will it take if an average rate of 8 miles per hour? Anyone take a stab at it? Now, what does the rate 8 miles per hour mean? What if I were doing 60 miles per hour and I drive for an hour? I would go 60 miles. Okay, so now this next one, 8 miles per hour, and I'm trying to go 10 miles though. Okay, so it's going to be an hour, right? So at least an hour. So after 1 hour, so let's try to do the math on it. So after 1 hour, we went, wow, that was an equal sign, but turned into a plus. All right, we goes 8 mile, right? How many more miles do I need to go? 2. 2 more miles, right? So it's going to be some fraction of that, right? So some fraction of that. So if I know every hour I go 8, what about half an hour? 4, right? In half an hour I would go 4, right? 4 miles? Okay, let's try that again. So what about half of a half? 2. What is half of a half an hour? 15 minutes, right? So that's a quarter of an hour. So it's 1/4 of an hour. So that tells me that it's going to be plus, right? 15 minutes. So if you notice what we did there, we took the information we have and broke it up into manageable pieces. Now, there's another way I could have done it. I could have also just written it as a fraction and said, hey, this could be as a fraction. I have that 1, right? 1 hour, and then it's going to be 2 out of 8, which is 1 1/4 hour. Okay, so that's another way of actually trying to do it. But we also try to do it with minutes there. How long will it take if she bikes an average rate of r miles per hour? So let's go back to how I wrote it like this. Can I write that as an improper fraction? Say yes. Yes, I can. If I were to write it as an improper fraction, that means the number on top's bigger, right? So it would be how many miles?
10.
So I would write it as 10 over 8. Okay? So it actually works out like this because it's 10 miles over miles per hour. MI divided by hours. So that's another way of doing it. Okay, so now let's take a look at number 2 now. Looking at number 2, how long will it take if she bikes an average of r miles per hour? How would I write that one? 10 over r. And the miles divided by whatever my rate is. Okay, and that's going to tell me how long. Karen wants to join AMP, but only has 45 minutes to exercise. what would your average time be to finish on time? So, now I know that this is the setup. So I need to figure out the rate. Okay. So I know it's going to be 10 over R is equal to, okay, so 45 minutes. How would I write that in hours? It would be 3 over 4, wouldn't it? It'd be 3 over 4. 45 minutes is 3/4 of an hour, isn't it? Okay, because my rates, if you notice, these are miles per hour. And this one says minutes. So that's why I'm actually looking at it in terms of hours now, because it makes the math a whole lot easier. So for my time, it would be 45 is 3 over 4, right? Yes? Okay. So I could solve for this by doing something called cross products. Multiply this way, gives me 40. So I'm multiplying right here, and then I multiply right here. Divided by 3. That doesn't go in evenly, does it? No. What do we get? Should be 13 point. And what is that? What is that number right there signify? What are my units I'm using for that? Miles per hour. So my rate is going to be 13.3 miles per hour. So if you notice, I keep writing this a different way. They all mean the same thing. So MI divided by hours is still miles divided by hours, or miles per hour, or MPH, which you guys are probably used to seeing, because every once in a while you guys might actually drive a vehicle or take a driver's test. One of those things, like cars, boats, RVs, whatever you guys drive, golf carts. Yeah, okay. All right, so we get that. So that's going to be my 13.3. All right, let's look at the last one. What will their average rate to be if they have T hours to exercise? T hours. How did we do this last one? T over 4. Not 4. You don't need the 4. Why did we have 3 over 4? It was 45 minutes was 3/4 of an hour, right? What if it was 30 minutes? That would be a half, right? That would be 1/2. But what if they only had 1 hour? I would just be 1, right? So I wouldn't have to have a fraction there. I would just have, but in the case of setting it up like the cross products like I'm doing here, I would just put T over 1. Okay? So T over 1 or for that to work out correctly. Because doing cross products, you need to actually have a numerator and denominator. So we need to actually have that set up like that. So let's see. So again, it's going to be 10 over R. So if I don't know what the R is, would equal just T over 1. Now, I'm going to do a little finagling. Here's some voodoo magic. Multiply these two. I get rate times time is equal to 10 times 1. What did 10 times 1? Where did the 10 come from?
10 miles.
Miles, right? And that miles is a measurement of, if you say distance, you get a high five. Distance, good job. There we go. Rate times time is equal to distance. So you might have seen it written out like that before, but this is the basic of everything. So you can manipulate this as necessary, but there it is. All right, so, but yes. Karen plans to bike 10 miles. Write an equation that gives his... It's a him? It's a him? Karen's a... All right. That's it. Okay. His time in t in hours as a function as a rate r in miles per hour. Okay, so let's go back to what I just said. I said that rate times time is equal to... There you go. So now I want it as a function of his rate in miles per hour. So what does that mean? So he gives his time in hours as a function of r. So right here, so I wanted to say t equals. So what would I do to manipulate this to get it to be t equals? Divided by? I want t by itself, right? So if I want t by itself, so I need to get rid of r. To do that, I divide by r. So that's going to give me t is equal to distance over rate. And that's what we started with at the very beginning. Okay, so now if my distance is 10, and it says graph this right here, so it says it would be t in terms of r, so my variables r is going to be distance, which is 10, divided by r. So now we're going to go to our handy dandy calculators to graph these. So I know everyone got their new calculators, right? So everyone got their new numbers. I don't have to yell at anyone like, hey, who stole the wrong calculator? Okay, so we're bringing up the graph. So on your calculator, everyone right now, on your calculator, bringing up the graph. Ugh, dying here. Jade, when you drink and you goes down the wrong pipe. Oh, that sucks. All right, so how am I going to write this function? Take a guess. Wow, you guys are super talkative today. Should I start a class with like jokes and stuff? Yeah, I should have. Okay, I'm not gonna pause it because no one watches the videos anyway. All right. So, you guys ready for my kindergarten joke? Okay, so hopefully I could actually get everyone's attention. You guys might like my kindergarten joke. So I need someone to actually help me with this. So, Gisele, can you help me with this joke, please? Okay, so now, so there's two people. Okay, there's Pete and there's Repeat. They're on a boat. So Pete falls off the boat. Now who's left? There were just two people, right? So who is the other person? Okay, so it's not too confusing. All right, you ready? So Pete and Repeat. Okay, they're on the boat. Pete falls off. Who's left? Okay, so now now listen to it carefully this time, okay? So now it's going to be Repeat and Pete. They're on a boat. Pete falls off. Who's left? Okay, so now, listen. So now there's Pete and Repeat. They're on a boat. Pete falls off.
Joke, you're just gonna repeat yourself till like.
Yeah. Yeah.
Can you please don't kill
It wasn't that funny.
Hmm?
It wasn't funny.
I'm usually pretty good at picking out someone that doesn't get it until like the fifth time, but you know, he got me on this one. So usually I have to go through like 5 or 6 times before someone, and then like 30 minutes later into class, someone else is gonna be like, I get it. And so watch, we're gonna record it, so all of a sudden someone's gonna laugh like 30 minutes into this video.
I don't think anyone's gonna watch it.
Okay, I don't think, yeah, no one watches it anyway,
I'll
right?
watch it.
You'll watch it? Okay, all right. All right, so that was my kindergarten joke. Yeah, so I've been telling that joke since kindergarten, just so you know. Okay, every year. I am all for recycling. I recycle my jokes also. All right, so now, class.
Yes.
Let's try this again. Class.
Yes.
Class. Okay, so what is the function I'm plugging in? What is the numbers? Tell me what I'm writing in here in the calculator. 10 divided by r. But in this case, these are in terms of x's, right? So am I putting r in my calculator? No. What am I going to put? X. So what am I writing on the calculator? 10 over x. Very good. All right, 10, control, divide, and then there's my x. Bam, there we go. There's that mother function.
What?
That's my starting function. That is the mother function. See, if it sounds like curse words, everyone starts paying attention again. Yeah, all right. Y'all horrible. Anyway, all right, so what is that note? What do you notice about that? What do you notice about this function? Eric, is your calculator not working? You are touching it aggressively.
It is working.
It is? Why are you so aggressive?
It
What?
won't press the fraction.
It won't press the fraction?
It won't go over.
It won't go over?
10.
Did you do control divide? Let's copy it. I heard so much. Control divide. You have to hit control first. Okay? Don't get mad at the calculator. All right, so there we go. So we have graphed it. Now let's go back to our page that says we're supposed to be doing something with it. We graphed it. What is the meaning T of 8? What does that mean? Go back. What does T of 8? So what variable is the 8 replacing? R. And the R is my rate. Very good. So R is the rate. So now, what is it saying when it says T of 8?
8 miles per hour.
8 miles per hour. So what's the meaning? Okay, so right here, 8 miles per hour. So let's go back to my graph and let's see what 8's going to look like. Here it is, and I don't think it goes. Does it go up? 1, 2, 3, 4, 5, 6, 7, 8. There you go. So 8 is going to be right there. So let me hit this menu, trace, graph, and I want 8. Is it off? Oh, I think I'm zoomed in too far. Zoom, standard. There's 4. There's 8. So, was that correct? 1 and a quarter. As a decimal, didn't that what I had on my first page? Yeah, the 1 and 1/4. 1 and 1/4 hours. Yes, there it is. So I can pick this out. This does make sense right there. So I could actually put that in there. This means when 8 miles per hour, and yes, it is, what was it? T is 1.25 hours. Yeah, that was right. That's what we had at the beginning. What is the meaning of T of 0? Now, what is the zeros replacing?
R.
R. Okay, very good. It's replacing R. So now think about it. Think about it. If R is 0, you're not moving, right? So if you're moving at 0 rate, how long is it going to take you to go 10 miles? Forever, isn't it? You're not going anywhere. So let's go back to the graph and look to see what that says. Okay, right here at 0, you notice, hey look, way up here, right? So we know this goes way up here. So it's going to be a whole lot of time, right? It's going to be way up there. So at 0, what is actually happening is that there is an asymptote. There's an asymptote because it's got 0 rate of change. Okay, that means it's not moving. And we say that it's, okay, makes sense? Yes, not moving. Okay. As r gets closer to 0, what happens to the behavior of the function? As it gets closer to 0. So now, if you notice, I got a little spot right here, right? So watch what happens to my numbers down here on the bottom. Watch what happened to these numbers. As I get closer to 0, what's happening there? Keeps increasing, right? Keeps getting longer and longer. I jumped over too far. That's as far as I can go on this graph. So if I keep graphing it, it's still going to keep going, but I can't go any further because it jumped to the other side of the asymptote. So right here, so that means as my rate gets slower and slower, it's going to take longer and longer, right? It's like walking to class and you're behind that person that is just barely crawling to class. And you're like, man, I need to get to class, I'm in a hurry. And you're trying to walk fast, but you know darn well that person's going to slow down in front of you. Okay, it's going to take longer and longer. So slower the rate, the longer it will take. As r gets larger and larger, what does the end behavior of the function tell you? So now, if r is getting larger, which way on my graph is it moving? Large r's. What did we replace r with in my function? What do I replace r in my function with? With x, right? So now, on my graph, where are the big x values? On the graph, where are the big x values? Are they on the left? Are they on the right? Are they up? Are they down?
Right.
Are they right there in the center, right where it's 0? So the big x values are where? They're to the right, aren't they? So if I count here, starting here, this is 0. That's 0. The numbers, the positive numbers, x values are to the right. The negative x values are to the left. Positive to the right, negative to the left. Yeah? Okay, so that works, doesn't it? Okay, so now let's see. As r gets larger and larger, what does the end behavior function tell you about the situation? So big R's, what does that tell you about? What is my output here? What does that tell me? What's my output here? As this keeps getting bigger, and I guarantee you, some of y'all mamas did this on the way to school. Come on now, come on. That was a funny joke too. What does R represent? The rate, miles per hour. Yes? Miles per hour. So what is this miles per hour right here that I have on my screen? 57 miles per hour. So what does that tell me? If I'm doing that in the school zone, I'm getting a speeding ticket. I'm going fast, right? But what does that do? What is this output? What does this over here represent? The time. So the faster you go, the slower the time. The faster you go, the quicker you get there. Right? Yes.
I thought it was a teacher who got a speeding ticket.
So good jokes, yes. Yes, not just speeding ticket, but they got locked up.
Oh,
Yeah. Yeah. They had to drag that teacher out of the restroom. That was funny. It's hilarious. I really wish someone had it on camera. You know, students record everything. So, yeah. So, every time there's a fight here at school, I'm like, hey, dude, let me see it. And, yeah, I could I could walk down the hall and ask someone, hey, who's got video of the fight? And I'm like, oh, dang, look's right here. Yeah. Anyway. So, yes, we got a teacher in the school zone, right? Because they decided not to leave their house on time, so they're leaving, you have, let me see, that's like 1 minute until, the bell rings. So, let's go back to this. As R gets larger and larger, what does the end behavior of the function tell you? So, faster rate. So, a faster rate. What about my time? It's a smaller time, right? Okay, then. So faster rate, smaller time. So in the previous one, slower rate, the longer the time, right? All right, so I have this like cool activity that goes with this. It's actually not very cool. Anyway, it's kind of lame. So I think I'd rather actually just give you guys the time for the working on the assignment for this. I'll make my other classes do the activity. So, it's just matching graphs. I don't know if you guys, are you guys good with this? No? Do you guys want to match the graphs? There might be some coloring involved. You want to do some coloring?
Yeah.
No? No? I got a couple people back here shaking their head yes.
For extra credit.
No extra credit. Man, seriously. Just take your Flintstone vitamins and just leave me alone. All right, so go ahead, like, share, and subscribe. Oh, wait. Before I do that, let's go back to the first page. Now, I said that this is going to be hashtag 53. So, page 53 in your notebook. Page 52 is where you could do some of the work now, because the practice that you guys have is going to be turned in by hand. Okay? So, go ahead and, all right, like, share, subscribe.